The Building Show, where ideas connect. For 34 years, The Building Show is where people connect through Construct Canada, PM Expo, Home Builder Renovator Expo, and the World of Concrete Toronto Pavilion. Visit the Metro Toronto Convention Centre South from November 30th to December 2nd to make the connections which will give you a competitive edge. For more information, email events@informacanada.com or visit thebuildingshow.com. Hello, everybody. Welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me today I have
Scott Jenkins, CEO, co-founder of ZS2 Technologies.
And that's where we're going to start. What's the origin story of ZS2, which is based in Calgary, we should say?
Yes, ZS2 based in Calgary, but expanding rapidly throughout North America. ZS2, I tell people we're a COVID baby. I don't know if that's good or bad, but the company started in early 2020. My partners in crime, Kristen Davis and Dr. Doug Brown, we got together, and we had previously worked at a couple different companies where magnesium cement products, we were exploring their uses both for interior construction and exterior. And really, Kristen kind of gets credit saying, we're all working from home now, and what better time to kind of take a chance on ourselves and see if we can change the world a little bit.
Mm-hmm. Now, you mentioned magnesium, which on your website and in history books, it said it's been used for thousands of years, but now you're using it in a different way. So maybe you could explain, what you're using it for.
Okay, so that's actually a great question to kind of kick us off a little bit. So I find this fascinating, but a little history lesson on magnesium. Magnesium is actually one of the world's original or oldest cements in terms of formulations. Magnesium cement was actually the binding agent for the mortar for the Great Wall of China. It's the Roman aqueducts. It is the Brooklyn Bridge. It is, the Pantheon in Rome. But the challenge with magnesium as a cement is twofold. One, it's not readily available in parts of the world, not geographically available. And two, it's also known as a saltwater cement. So it's can be corrosive. So we've been exploring here at ZS2 ways to address those two challenges, which I'm sure we'll talk a little bit about. But Portland cement, ordinary cement, which was invented in the 1800s, has overtaken magnesium cement because limestone, which is used for the creation of Portland cement, is readily available in most parts of the world. So just access. So if you think about it, limestone and cement, which is interestingly another little tidbit, the second most consumed product on the planet other than water by humans. We use a lot of it, but limestone's everywhere. The challenge is, there's an environmental cost that's very high with using cement, and magnesium cement doesn't have that environmental cost. So our focus at ZS2 has really been to focus on high value precast products, if you will, like manufactured products, and try to use magnesium cement, but address those two challenges of geography and the chemistry.
And maybe we get into that a little more, because it seems like the driving force behind this company is carbon capture and carbon reduction in the atmosphere. So how does magnesium help with that?
So I'll try to be a little more brief on this answer. Really quick, take a step back. Ordinary Portland cement, limestone cement, normal cement that we use, our sidewalks, foundation of our homes, our buildings. So that is created by taking limestone from mountains, rocks, quarries. You crush it, use a lot of energy, but then you heat it up to 1500 degrees Celsius to create a chemical reaction. So limestone is calcium CaCO3, but we need it to become calcium carbonate for cement. So you're heating it up using all this energy to actually get rid of the CO2. So it's a double whammy, that CO2 that's been embedded in rock. So for 1 ton of normal cement, it's estimated you create 1 ton of CO2. Magnesium oxide and magnesium oxysulfate, two benefits. One, you do have to heat it up a bit to create a chemical reaction, far less, but magnesium actually likes to bind with CO2. It's a wondrous element, magnesium. So you can reduce the carbon footprint significantly in cement. The second piece, you alluded to it, is we're free to talk about it a little bit. We've patented a process that really takes direct air capture or flue gas CO2 And not only does magnesium like to bind with CO2, we actually, we pump CO2 into our mixture. And because magnesium likes to bind with CO2, it actually makes our product lighter and stronger. So we're not just sequestering carbon. The carbon dioxide makes our product better.
Mm-hmm. And you also repurpose, or this might be what you just explained, oil and gas waste, which of course there's plenty of in Alberta because of the industry. So without giving away any secrets, how does that work?
So, again, we're starting to talk a little bit more about this. It's complex, so I won't get into complexities. But there's a lot of companies out there right now that have discovered that obviously there's a tremendous amount of water pumped in Western Canada, so Alberta, Saskatchewan, Northeast British Columbia, Manitoba, and that water is very salty. In some places, 100 times saltier than the Dead Sea. Well, the third most abundant element in salt water is magnesium. So we use wastewater from, it can be from oil and gas industry, or we actually have some discussions, so I can't go into details because we hope to make a very exciting announcement here shortly, with a couple companies we're in detailed discussions that are mining, if you will. They're not really mining, but they're taking lithium, of course, for battery or electrification,
Right.
that industry, out of these wastewater brines. Interesting, the lithium molecule is very consistent in size to the magnesium molecule. And so it's a waste product for them as well. And they don't know what to do with it. So we are using already at lab scale, and we're about to commercialize. So it's proven out, if you will, salt water sourced here in Western Canada, magnesium oxide sourced in Western Canada, and then obviously CO2. And then there's some other kind of tricks up our sleeve that we won't discuss today that make it a little more complex. And there we are, where we have a cement product, a cement board, which we call TechBoard.
Right, and that's one of the three. You have TechBrick, TechBoard, and TechPanels. So what are the differences and similarities, and what are the applications for these?
So TechBoard would be, whether it's an 8x4, 9x4, 10x4 sheet. So it would potentially be a, highly, highly fire resistant and sustainable replacement for OSB, Type X drywall, a sheathing, if you will. So a construction product. High strength, impervious to mold. So for any wet environments, it's great. It'd be great for any, food production facilities or greenhouses or, even our homes, in terms of air quality. But then again, the fire resistance is where there's a lot of interest from our clients. Then we take that tech board, and then here in Calgary, we manufacture we call it our tech center, but our manufacturing plant, we use the tech board to manufacture structurally insulated panels. And I'm sure many of your listeners will know about SIPs, is kind of an industry term, structurally insulated panels. Historically, SIPs have been built using OSB, or there's a lot of metal insulated panels. That's a big booming business for like walk-in coolers or big food production facilities. So we use our tech board rather than metal or OSB to manufacture our tech panels, which are structural panels for construction, residential and commercial construction. TechBrick is a little different. TechBrick is a product that we have manufactured for us in Europe, and it's an elastomeric thin brick that has all the properties of a actual brick, but it's much quicker to install, lasts just as long. But because it's not a kiln-fired brick, it also has a much lower carbon footprint or energy footprint to manufacture. So TechBrick would be a little different, and it's an exterior aesthetic finish. Looks absolutely beautiful, but we have a European partner that actually manufactures it for us.
Okay. And as a startup, I would assume there's a lot of computers where, say a big company would just go with the tried and true that they've always used because they've been around for 100 years. You guys don't have that option. So how does computers work into the mix of this? Because I'm sure they do somewhere.
Well, so when we founded ZS2, we always said, we're a science company. We're a material science company, but we're a technology company operating in construction. We have manufacturing, we prefab panels, so reducing on-site labor, speed, giving our customers some cost certainty. But it's really about the material science. But we also said, so this is why this is a good question. We also said, look, we have to embrace all technologies, whether it's our design software, our processes. How do we interact with our teams? How can we be better? And I was fortunate enough to work with a company called Dirt Environmental Solutions
Right.
from the very beginning. And when I left Dirt, I was the president, and we built up that company. But one of Dirt's kind of foundational pieces, and still is for them, is their ICE software, which was built on a video game platform. So I learned a lot about using technology to kind of hopefully address some of the challenges in conventional construction projects. And I'll just let from my perspective, my opinion is conventional construction. One of the challenges is, of course, just the flow of information with so many subcontractors, general contractors, the client, maybe an architect, maybe a project manager, maybe the developer, and just somebody's looking at version 18 of the drawings, but somebody's looking at version 22. Maybe the window manufacturer is looking at version 12, and then we wonder why things don't fit together well on site. So to your question here at ZS2, we're looking at more using off-the-shelf products and solutions, but we're always on the search for, what can we use for our design software that feeds potentially information to our shop floor, to our estimating tools. And the truth is there's wonderful tools out there that are much more cost effective than they were, say, 15 years ago.
That kind of leads to my next question. Calgary is obviously known for oil and gas, probably more than anything, but it's also an emerging tech hub. Does that help with what you're doing?
So it's been fascinating, as we started ZS2, and our team, our wider team, many of us come from construction technologies, distribution channels. Obviously Doug is a PhD chemist. Danny on his team's a PhD chemical engineer. So decades of experience. But in the past couple of years here in Calgary and Alberta, overall, really we've sort of been welcomed into this tech community that I didn't realize is growing and is so large, and the momentum is just building. And I think it's partially, I have some opinions just, living in Calgary a large chunk of my life, that there's just a big entrepreneurial spirit here. And so people are looking for innovative ways to do things, and there's people willing to invest in that.
Okay, and speaking of investing in things, in an interview with, I think, the University of Calgary, Dr. Doug Brown, he was talking about how they're doing a carbon capture to cement plant, and that should be up and running in a few years. And I don't know what you can tell me about that, but what's the process involved in building something like that? I assume it's much different than a regular cement plant.
So yes, a little bit different. Obviously, it's our proprietary formulas, a little bit what we've touched on, but there's some other critical pieces to that. For us, we're very lucky that we have strategic partners, a company by the name of Progressive Planet, which is a public company doing an amazing job out of British Columbia. So they provide us with critical inputs. And one of our critical Alberta partners is a company called Baymag, which is Canada's only source of magnesium oxide. And it's one of the purest magnesium oxide sources in the world. And Baymag's parent company, Refra Technik, is a German company that's been focused on magnesium for other industries, i.e. animal feed, water filtration, refractory, which would be like high heat ovens, industrial purposes, out of Germany. So we have our partners close by. And so, in terms of raw materials, really, we will put that together. And then we're right now just in the design phase of the production line and the building. So it's actually probably, I know Doug had mentioned in that interview, I remember that interview now that you mention it, that it might be up and running in 5 years. I would say probably within 2 years.
Oh, okay.
And I can't share, but we've recently received some very exciting news as a company in terms of support from our government, and that's going to help accelerate things. So that's great. So we'll be making an announcement here in about 3 or 4 weeks, I hope.
Okay, and if anybody listening is interested in what ZS2 is doing, or ZS2, however you pronounce it, or wherever you're from, where would they go for more information?
So easiest place is obviously the website, which is ZS2, the number 2 technologies.com. We have a learning center tab that has a whole bunch of information, all of our certifications, testing. We've invested heavily in that because we're a new building product. So if you can think about things, construction is one of the world's largest and oldest industries, but there's nobody more powerful than the building inspector, and it makes sense. So we have all of our certifications and testing, continue to invest that. So you can find that. You can also find our recently released, and it's public, LCA, life cycle analysis, and environmental product declaration with SCS Global. So you can go to their website, SCS Global Services, or our own. So that's probably the easiest. Or to be honest, we love it when people come for a tour. If you happen to be in Calgary, Alberta, come see what we're doing. Come visit the lab. We love showing people what we're doing.
Okay, great. Thanks for joining us today, Scott.
I appreciate it. Thanks so much, Warren.